Hello everyone, my name is Ankit and today I'm going to talk about our case study, a smart home for elder people. The first part is case study overview. Most adults would prefer to remain as active as possible and to live independently in unrestricted environment they age. However, because illness and declining health affects most people as they get older, placement in more restricted housing environment like assisted living or nursing homes is fairly common. The reason this sort placement occur is because health assessment and medical care have traditionally required face-to-face meeting. This is not necessarily true through in current technological age where there are alternative means for healthcare providers to reach aging adult with illness to conduct a health assessment and suggest medical treatment. One alternative consideration for monitoring older adults include the use of smart sensor technologies which detect activity level around them, electronically send the activity data to a central repository, and then through web technology data can be assessed and viewed by health care providers, families, and other interested in the health of the older people being monitored. There are practical and ethical issues that have to be evaluated before smart sensors should be deployed in any setting. Practical issues that needs to be identified include what type of sensor are going to be used and what type of information will be captured. Sensors can be worn on body placed on so they come in contact with the person, or they can be placed on by being mounted or situated throughout an apartment. A network-based sensor environment with embedded artificial intelligence, various vital signals like blood pressure, electrocardiograph, body temperature, restlessness, fall, and gait pattern can be measured using various sensors including vision sensor, electronode with electrical amplifier, pressure sensor, light sensor, sound sensor, temperature sensor, etc. Choice made about the type of sensor information capture raise several ethical considerations about the, their use. Sensor network architecture. The sensor network under development is shown in diagram. The network includes six main components: a passive psychological sensor network with the data monitored and mentioned sensor, stop sensor, body sensor, and event driven video sensor network that helps identify features of resident, a reasoning engine that fuses sensor and video data and analyzes pattern of behavior activity, a flexible alert manager, a component for providing customization of sensor configuration, alert specification, and data access for each resident, and a database server and web interface that provide interactive retrieval and visualization of sensor data. Collected data is transmitted to the database, can be accessed via web server. The next part is type of sensor. The first is motion sensor. Motion sensor detect presence in a particular room as well as specific activities. For example, a motion sensor installed on the ceiling above the shower detects showering activity. Motion sensor installed in a cabinet and the refrigerator detect kitchen activity. The next sensor is bed sensor. The bed sensor is installed under the bed lines which detect presence in the bed, qualitative pulse and respiration, and bed restlessness. The next sensor is stove sensor. The stove sensor detects motion in the kitchen as well as temperature of the stove or oven unit. This is done through a modified X10 PIR motion sensor. When a high temperature is detected, a stove on event is generated. The next part is key users. The key users of this smart home for wellness is elder people or target people, their family members, and healthcare providers or doctors. The next part is wireless protocol. Zigbee protocol used to communicate between devices. Zigbee is an 802 wireless communication standard built by IEE. Much like Z-Wave, it's seen significant growth in the past few years and can be found in a relatively large number of devices. It also consumes very small amount of power and use a mesh network structure to offer excellent range and speedy communication between devices. The next part is business benefits. Studies have shown that using smart home technology can reduce hospital admissions and decrease the length of stay if admitted. According to a report by Australian Academy of Technological Science and Engineering, a 10% reduction in number of accident falls would save the Australian healthcare system about $85 million a year. The same report found that the application of smart home technology could not only offer saving in public and private sector but also improve the quality of life of elderly people by minimizing fall and accident in the home. The main advantage of smart home technology that it allows the elderly to stay in a familiar and comfortable environment and delay on avoids admitted to a nursing home. The next part is future development. For future development in smart homes, it could be expanded for the help of handicapped people. These are some references. Thanks for listening.